Last time then we were talking about attributes, and I showed you a number of attributes, some of which come from the .NET library itself, some from third-party libraries, and I promised you we were going to look at how to write our own attributes. But I realised that in order to use attributes, you've really got to also use reflection, and so I thought I'd further break this up into two, and this week we're going to look at just basic reflection, and then next time we can look at reflection and custom attributes. And the application I was going to show you is a simple reporting tool. So we have some data that we've got from a database or wherever, it's in memory, and we want to generate reports, we want to generate documents that we can distribute to people to show summaries of this information. And the format I've chosen is just about the simplest one there is for this, just as a simple example, which is CSV files, which stands for comma separated value. And so the idea is our data is broken into rows simply by having a carriage return, and those rows are broken into columns by using commas to separate each field. And then this format is very simple because it's just a textual format, but it can be loaded into things like spreadsheets, Excel understands it, other tools as well. And so it's a really easy way to get our data out into some general format. And so the data structure I've got here, I've got a couple actually. We've got this class book that you can see has an author, a title, date of publication and rating, and then I've thrown together some dummy data for that. But then also, because what we're trying to do is produce a general purpose tool, I've got another completely unrelated data type, which is weather, where we have city, description, temperature and rainfall, and then you can see I've put together some dummy data for that as well. And then to start with, I've already written a CSV generator, but it's a CSV generator that is fixed for books. So what we do, if we look at the main program, is we create one of these things, we pass in the data structure, so that's our dummy data for books, and also the name that we want to give to the file, so this is just going to be called books, and then we call generate on that, and that will produce the CSV. But as I mentioned, it's currently hard-coded for books, so at the moment we couldn't do the same thing for weather, we'd have to write something more specific. But to start with, let's just take a look at how this fixed version for books works. It takes in the INUMBL of books and the file name and just saves them, and then the generate function creates this list of rows. It adds to the rows a header. It adds to the rows a row for each item, so we've just got a list of strings, and then very simply we can just do file write all lines, format this CSV file based on the file name, pass in the rows, get the encoding right, and that should generate it. And then if we look at things like the create header, that in this case just returns a comma separated list of those column headers that we're going to have. And then on the create row we have a string builder, and we just put in the value of each one of the properties that we know we have for a book and put the comma on the end because it's comma separated values. One other thing we'll do, because we've got this date of publication as a date time, we do some formatting on that, and so we do a toShort date string. All the others are either strings or an enum, which has a perfectly good toString, gives us the string representation of the enum. We return that. That adds onto our row, and then we create all the lines. So if we run that up, the console doesn't tell us anything at all, but if we then drill down and go into File Explorer and go down and down still further, and there you can see we've got our books.csv. It's marked as an Excel file, but I will open it up just in Notepad first to show you that it is just text. So there we've got it in Notepad, and you can see we've got that header row with title, author, date, etc. And then we can see we've got the individual items. And also we can see that we've got the standard short date format, so 23/03/1959, that sort of thing. The problem with it is it's not columnated, it's not particularly easy to read, so that's why it can be easier to read if we just double click on it, and we'll get Excel coming up. And then we can just expand the columns to fit the width. So we've got the headers, then we've got the content. We've got no kind of special formatting on the header, but we could add that in now that we're in Excel. There's one weird little feature to note. You'll notice that those dates, some of them have been justified to the right, some of them justified to the left. This is actually nothing to do with what we're talking about here in terms of the CSV file. It's an irritating feature of Excel that it doesn't understand dates before 1900. So when it read in that text, when it saw these dates in the 1950s, if we look at the format there, then we can see it's interpreted that as a date and set some formatting. Whereas if we look at these in the 1800s, it can't make out that that's a date, and so it's just gone for general. So it's a bit of a quirk, but it's not to do with what we're doing. It's a feature of Excel. But there's a few things to note about the way we've done this that are worth remembering, because we'll see how they're not quite so easy to do when we generalize it. We've already mentioned the fact we've formatted the dates. Also, it's worth noticing that we've got a column there called date space of space publication, whereas the property name was simply, has to be all one word, date of publication. And then the other thing to notice is the ordering of those columns. We had chosen to go title, author, date of publication, rating, and that's because that's the order we want to display it in. It's not the order that they're actually declared in, and it's not alphabetical order, it's our specific order. So when we generalize this, we might think that's going to start to be a bit tricky, and indeed it is. But let's have a go. Let's just close that down. And so the way I'm going to do that is the very first thing that you'll typically do in any kind of generalization is we are going to make this generic. So I'm going to change this to a CSV generator for T, whatever that type may be, and then anywhere that this mentions books, I'm going to change that to T. And we've got one more to put in there, so change that to T. And you can see now it's reasonably happy, except of course down here where we've still got the specific code for a book. But if we go back to the program, that means now, because this is a class, we've got to use explicit generic instantiation. So I've got to tell it it's a generator for books. But the nice thing is now I can put in the one for weather, and again, as long as I instantiate that for weather, now those two are both happy. But I've still got to obviously make some changes in here, and this is where we start to make use of this idea of reflection. Because to do reflection, what we need to do is get hold of the type object for the data type that we're dealing with, either book or weather or whatever it may be. It can go well beyond all of those. And the way we can do that, let's actually put this in as a member so that we can use it all over the place. So we've got this type, which describes type information about every class, struct, enum, interface, every data type you've got in .NET, whether it's from a library or you wrote it for yourself. Each one has a type associated with it. So I actually use the keyword type of, and then pass in just T. That will give us the type of book or the type of weather or whatever it may be. And then let's start using that. So actually let's do this first in the header. And what I'm going to do in the header is I'm going to say var properties equals, and then take this underscore type, and on there you'll see we have all sorts of methods. We've got one, for example, called get members, and what that will give us is every member of any category whatsoever. So it'll give us the methods, it'll give us the fields, it'll give us the properties, and so on and so forth. Absolutely everything. And sometimes you might want that, but we're just interested in properties. So the idea of our reporting tool is we are only going to report public properties. So even if it's got fields which are there with data, we're not going to use those. We're just going to go for public properties. Could have done it differently, but that's why we're going to do it. And so in that case, I can actually already whittle this down by just calling get properties, and that will only give me the subset of the members of the class that are properties. I'm going to further restrict that, because although the default will give you all properties, we have actually got an overload that takes this enum binding flags. And so I'm going to say I only want public properties. So if it's private, it's none of our business. And also, we can OR these together. I'm going to say I only want instance properties. So that means non-static. So that's what I want. You can see all sorts of things in there in the binding flags, other ways that we can restrict it, but public instance is what I need. And then what I'm going to do is simply I'm going to create another string builder, and then I'm going to loop through the properties, and what I'll need to do is just say Bob dot append, and then we can do prop dot, and there it's got a name property, which is the name of the property, simple enough. And then, of course, the other thing I've got to do is pop on the end of there a comma, because this is comma separated value. And then we can get rid of the hard-coded bit, and we could return bob.toString, and that should give us the header. You might notice one slight problem we get there, actually. We're going to have a trailing comma, because it's appending the comma on every one of those. Now, actually, CSV is kind of relaxed about this. It's probably not going to cause too many problems, but let's be absolutely strict and get rid of that one. And a nice little trick, actually something that came in C#8, which I don't think I've covered in a video, so I may come back to this and show in a bit more detail, but it's the idea that we can do ranges in C#8. And so what I'm going to do here is just put square brackets, dot, dot, hat 1. And what that is saying is I want to take the string that's returned, but have a subrange of it from the beginning, so there's nothing before the dot dot, and then the hat 1 means 1 in from the end. So you could have done this before with a substring method or something like that, but this is a really neat way that we can reduce that, and so because we're going 1 in from the end, we'll lose that trailing comma. So that's our create header. And in fact, let's check that out. Let's just comment out the code there for now. So if we run this, we should now get 2 CSV files, but they'll only contain the headers. But it's always good to have a little check along the way. So that's run up without any errors. Let's go back to the folder, and you can see we've now got both books.csv and weather.csv. And if we open that one up, then you can see it's got the header information in there. And if we open the other one up, then you can see it's got the weather heading. So that's all worked so far. And there was nothing in there specific for books or weather, so clearly this is going to be a very general purpose way of generating reports. So the last thing we've got to do is just go through and actually get the values as well as the headers. So if we go back into our CSV generator, and then what we need to do here is on the create row, we actually need to do something very similar. So we're going to once again get hold of our properties, and then we're once again going to loop through them. So get rid of all of that. And then the thing is, though, we don't want the property name, we want the property value. And that is also available. You'll see on a property, we have actually both a set value, so we can use reflection to change values, but in this case, we just want to get the value. But the thing about getting a value is you can't just get the value on the property, because the property, like all of this reflected data, is simply the property on the class. It's not the property on the object. And it's only the property on the object, unless it's static, which has the value. And so when you do get value or set value or anything specific to the object, you have to provide the object as well, which is fine because that's exactly what we've got here in item. So if I put item in there, then that will get us the property of the item. And then we're appending the comma on there. And then again, we'll do the toString and remove that last additional comma that we don't need. And so that really should do the job for us. So now let's run that one up and take another look at our reports. And so you can see here we've got all of that information. So we've got the title, the author, and all of that data. The enums, toString on an enum gives you back its value. And if we take a look at the weather, then we can see the same sort of thing again. And so really, that's got it all working in a very general purpose way. We could have put a collection of any class in there and it would have looked at the public properties, given us the header, given us the content. But if you remember back to what I was talking about earlier when we had the specific one for book, the issues I highlighted there are now not quite as good as they were, because the ordering is now the ordering that we had it in the declaration. So if we look at our declaration of book, author, title, date of publication, rating, that's what we're getting on there, which may not be what we want. But what happens is when we do the get properties, it lists them in the order that they're declared in the class, which at least means it's the same. We're getting the right data in the right column, but it may not be what we want. Other things we highlighted, we've got that date of publication, just the name of the property without spaces, which doesn't look very nice. And then another problem we've got is it has had to go for just a general date time format, because all it could do is call a toString. It couldn't say we wanted short date or long date or whatever it may be. And again, you can see that we've got the slight problem that Excel hasn't really understood that for the older dates before 1900. But if we again look at this as text, we can see actually the format on all of those is exactly the same. So that difference is again Excel, not our program. So how can we fix those? Well, one of them, we could actually fix that date issue using a trick we looked at quite a few videos back, which is on what is known as dynamic overloading, where we can have different overloads depending on a type, even though we don't know the type at compile time. So what I could do here is I could put in, let's have a private string, and then we'll call this create item. And then firstly, I'm going to have a general purpose overload. So I'm just going to have an object, and all that's going to do is return item dot toString. But then I can also have a create item that's overloaded for date time. And in that case, I'm not going to do the toString, I'm going to do the toShort date string, which was the one we had before. So we've got those, and if we had other special cases, as we saw in that earlier video, we could have further overloads. But how do we get that overload? Well, what we have to do is we have to, on that append, we are going to say create item and then pass that in there. But that's not going to work yet, because at the moment that's using standard compile time overloading, and at compile time we've got no idea that this property is going to be a date time, it's just an object. So we also have to cast this to dynamic, which is what means it's now going to look it up at runtime, and therefore it'll get the correct behavior. And so if we now run that up, all works fine. And if we take a look at the output now on our books, we can see, again, failed for the older ones, but for the new ones, it's just got a short format. And if we now do that as text, just so we won't get Excel spoiling things for us, we'll see that it's done them in just that short date format. But we haven't been able to fix the problem of the headers looking like that. Also, if we take a look at, say, the weather file, we've got a couple of other problems. One is we haven't been able to do any formatting on those numbers. So that rainfall, I think we'd probably want to only be having to 1 or maybe 2 decimal places, but it just has to put that through there. And also, it might be a lot easier to read if, rather than having a header that said temperature centigrade, we could just say temperature and then put the units, both the centigrade and the inches, on the data itself, like you'd normally read it. But those are so many special cases that it starts to be very difficult to work out. In fact, even if you consider the formatting of that date on the book, that is a special case. The data type is date time. Now, in this case, we only want the date, but how do we know in other cases that we don't want the time as well, or whatever it may be? And that's the problem that we've got. And if we relate this back to what we were talking about in terms of attributes last time, the problem is that if we look at one of these properties, the only information that we have about these properties in terms of the C# programming language are the type and the name. So the fact that we've got this as a date time, that's the only information that's available. We don't know that it's a date time we want formatting for date or for time or whatever. If we look over here, when we've got a double, we only know that that's a double called temperature centigrade. We don't have any additional information such as how many decimal places we should display it to, or indeed adding a unit on there. Now we could, again as I mentioned last time, maybe adopt a naming convention. So the fact that we have ended that in Centigrade, we could have used reflection and a little bit of text processing to say, okay, we'll put degrees C on the end there. But it's a bit of a clunky ad hoc way of doing it, and that's why using custom attributes is a far, far better way of doing it. And so that's what we're going to do next time. We're going to introduce attributes that can describe what, for example, on a double, the number of decimal places should be, what the units should be, what the column heading should be, and maybe other things as well. So, hope you found that useful. Next time we're going to be looking at these custom attributes, but if you enjoyed that, do click like, do subscribe, and then you won't miss the next video.